Who here has been to lightning talks before or given one before? You should really put your hand down if you don't want to give one now, because I'm still looking for volunteers. Sheets up there. So, lightning talks are 5-minute quick talks. You'll get one idea out, unless you're James, in which case you'll get about 5. But you get 5 minutes. And this is the whole fun of it. You get 5 minutes, you will get cut off after 5 minutes. I'll be keeping an eye on the time. But you get to talk about any topic you like. It can be PyData related. It can be something completely different. In the past, lightning talks that I've gotten to enjoy at various conferences have ranged from... in fact, the ones that I haven't enjoyed, which come to mind most, is please come to my conference. It's on in 6 weeks. Please don't do that. We're not going to take those talks. But the more enjoyable ones have been things like how I lost my pants at the attendee party, which was a starring role at EuroPython. Everyone enjoyed that one. And also, someone completely analyzed Star Wars in, I don't remember the details, but that was interesting and a little bit heartbreaking as a fan, because the results were not what I wanted. But you can come up and talk about anything you want.
Are you going on first?
Yes. When it gets to 5 minutes, I'll give you minute warnings. So just so the speakers know, you'll get like a 5, 4, 3, 2, 1 at each minute from me. For everyone else, I'm going to start clapping when they get to 0 time left. And you're just all going to join in. And if the speaker keeps going, you're just going to clap louder. And if they keep going, you're going to clap even louder and start cheering. And eventually they'll get the point and they'll wrap up and leave. But that's going to happen at exactly 5 minutes. So even if it looks like they're saying something interesting, we're still going to cut them off. And they're going to leave the stage. And we'll get on with the next one. The plan is to be done by 6. Probably earlier if no one willingly volunteers to give talks. We've already bribed and blackmailed as many people as we can. Hi, Gina.
Hi.
And so our first is going to be Gina Helfrich. Take it away.
Okay. Hello, everyone. My name is Gina Helfrich. I am Communications Director for NumFOCUS, which is the nonprofit that puts on PyData as an educational program. And I also am the Program Director for our DISC program, which is Diversity and Inclusion in Scientific Computing. So my talk today is on how diverse is PyData and some challenges of answering that question for an international conference series. There are a lot of things I'm not going to talk about, which are of potential interest with regard to this, but just putting that out there. There you go. You would think that answering the question, how diverse is PyData, is potentially simple. What are the relevant metrics? Survey the community about them. Analyze the results. So let's start at the top. Select relevant diversity metrics. We've got tens of thousands of people in the PyData community, not only in our conferences, but also in our meetups. There are many countries around the world, approximately 3,500 attendees. So we have to kind of ask ourselves, if we're thinking about the diversity of a global community, what does that really mean? Are we thinking about it in terms of underrepresented? Well, what's underrepresented in the UK is going to look completely different from what's underrepresented in Japan, for example. So say we set that all aside and just go, Gina, what diversity metrics are. Come on, don't quit pulling my leg. So maybe we would track something like gender, sexual identity, race, etc. We can get into further things, right? Some other stuff maybe I haven't put up here. And if we do all that, I think then we have to ask ourselves the question of how do we get this information both accurately and responsibly. So if we are going to collect this info, how do we make ethical choices about doing that and categorizing and reporting the answers? So for example, if we collect all this stuff, we're going to have a hard time preserving anonymity, which might be very important for some of the people who are asking about, right? So there are quite a few things that we need to take into account. For example, if we ask about gender, text box is friendlier for people, but providing options is easier on the how are we going to actually sort this out side. Will we alienate people by the way that we frame the question? Are we going to potentially have women who are answering the question be primed to answer other questions later in a different way? Are men going to opt out because they feel like this isn't for them? If we ask about race, right? How are we going to distinguish race from ethnicity? Same question about text box versus providing options. It is an international conference series, so if we change it based on location, how do we think about that, right? Okay, so we have a lot of questions that we have to decide upon answers to and make our choices there. So let's just set all that aside and get to survey the community. You'd think this is the interesting and easy part. A great survey will get a 40% response rate. There's between 100,000 people at every conference. And for this crowd, I'm sure you're thinking, how are we going to even assess something like what that would mean, right? 10% of a 100-person conference, how diverse is PyData? And that really brings us to the question of how we have intention, questions about accuracy of this information versus collecting it responsibly. Because we could say, hey, we'll fix this problem by making everything mandatory. But if we make it mandatory, that's not very responsible, right? So responsible would be optional, accurate would be mandatory, so we have to negotiate these tensions. And then you analyze results and that's it. So I welcome your help.
Thank you, Gina. As an often underrepresented minority myself, I often wish that we had more Windows Phone users at these conferences. Mike, you're up next. And just to be prepared, it looks like Joe is up next, always ready. I have not prepared jokes this time to fill in the gap. You are welcome.
That was funny.
I didn't prepare it, that just happened. You ready? Yep. Okay, Mike Wendt.
Excuse me. Hi, everyone. My name is Mike Wendt from NVIDIA, and I'll talk today about GPU acceleration, how we're doing that with Go AI and Python. But before I explain what Go AI is, I think we all can agree about this, that the data struggle is real. Whether it's the data formats, there's many of them that are easier to work with, some of them more complicated. Once you figure out your format and what you're trying to do, then you start becoming, there's the processing part. So, if we think about the evolution of where we were at, Hadoop, batch, disk space, very long times, then all of a sudden there was this revolution, right? We went to Spark, 25 to 100x speed up with less code. The language was more flexible. You could do Python, Scala, Java, and it was primarily in memory, so we got this tremendous boost in speed. However, somebody was like, GPUs for the win. We're going to be able to bring them in. They're going to change everything and everything will be faster. And the first time around, it didn't really work out too well. We got like a 5 to 10x speed improvement. But the biggest problem here that was like a barrier for most people was there's more code. The language is more rigid. You have to learn this thing called CUDA and program in C, and then try to get that C kernel with the CUDA, to talk to your Python code. And it kind of hampers things. So my colleague Keith and I, we joined and we were like, we can do better about this. We can actually help the community do some awesome things because there's these GPU accelerated technologies out there like MapD, BlazingDB, which are GPU databases, Anaconda and H2O AI for processing and analytics, and then Gunrock for graph analytics and GraphStreet for graph visualizations, all based on the GPU. And what we found was these dreaded copy and convert. So that's all these red arrows. We don't like these because this is what's really going to hamper anything. GPU's fast when it's on the GPU. If I have to go off the GPU, everything just slows to a crawl because I have to go through PCIe bus, hit the processor, come back. So even in this small example, how I want to move data from MapD to GraphStreet to visualize, I got to bounce through the CPU. So ideally, we want to get rid of that, right? It's no more. If it's on the GPU, I should be able to share it. And that's where Go AI or the GPU Open Analytics Initiative came in. And we launched this in May. So it's a shared GPU data frame that now I can actually hand off between all of these GPU technologies and stay on the GPU. So once the data is there, it's there. I basically hand off a pointer. Now, this now transforms how you're doing a data processing pipeline because now it's all on the GPU, from ingestion to parsing, exploratory analytics, the whole pipeline. And it was pioneered by MapD, Anaconda, and H2O as the founding members. And then BlazingDB, Gunrock, and GraphStreet has also picked it up. Now, How easy is it to use? Simple Python import statement. I'm going to import the PyGDF. And everyone here loves pandas. That's what we usually use. But in one line, I can actually go from a pandas data frame to a GPU data frame. And then by using some decorators in Numba, I can actually tell it, take this code snippet, and I want you to compile this down into CUDA. I don't have to learn CUDA. I don't have to do all the kernels and that kind of stuff. Numba actually takes care of all this for us. And big shout out to Anaconda for doing a lot of the work on this. But it just doesn't stop there. So there's a lot of growing community support for those of you that might know Apache Arrow. Wes McKinney, we've been working with him. They're actually starting to add GPU support into Arrow. Why is that important? Because the CPU technologies are having the same problems. When you're trying to go from like Spark to Kudu, Cassandra, what have you, you're doing the copy converts, and we want to get rid of that. So the GPU data frame is actually Arrow compatible. So if you're pulling data out of these other places where the Arrow memory is, you can actually pull it into a GPU data frame, then be able to do all this processing for model training, inference, data manipulation, all on the GPU, and then save the information back and forth without having to do all this copy and convert serialization. So where does that bring us in our processing evolution? Finally, we're at that point that we really wanted to get to, of that 25 to 100x speed improvement. We're using the same code. We're just adding the little decorators here and there to do that. And we're doing language flexibility because, keeping it in Python. So here's how you guys can get involved. Links to the GoAI website. There's actually Docker demos with Jupyter notebooks and that kind of stuff if you guys want to see how it all works. Encourage you to check it out. Keith's back there, and I'm here if you guys have any questions.
Thank you. While Joe's getting plugged in, who made it to the PyData quiz earlier today? New few people. Good. For everyone else, I'm going to throw a couple of questions from that quiz at you, since you weren't there and you don't know the answers. Who can name a feature that is new in Python 3? Just call something out. F-strings. Oh, everyone's favorite. Anything else? Matrix multiply. That's you. Do you know exactly which version that came in? 3.5. Async. New in Python 3. Sorry? Async generators. Is that really a feature? Those are scary. Anything else?
It's on me. Don't worry.
What about a new feature that was added to 2.7? 2.7. Set comprehensions was added in 2.7 compared to 2.6. The uninstall feature was not new, but it is recommended. Joe, take it away.
All right. Thank you. So today I'm going to talk about a little toy library I wrote to implement a feature called Stream Fusion. So what is Stream Fusion? This is to solve two problems. The first problem is when we have code that looks like this, where we have map of F, of filter of P, of map of G. Basically, we have some sequence of interleaved calls to map and filter. The other problem that I want to solve is when we have code that looks like this, where we have map of F of map of G. So when you have long sequences where you're mapping different functions over the same sequence. So as a quick refresher, map is a function which, given a function that acts on a scalar value or a single element and a sequence of elements, it applies that scalar function to all elements in your sequence. However, it does not mutate your sequence, so the original sequence is preserved. Filter is a similar function where, given a scalar predicate and a sequence of values, it evaluates the predicate on all of the values and takes only those for which the predicate evaluates to true. Again, it does not mutate the original sequence. So given some code that looks like map of F, filter P, map of G, what is the actual problem with this code? So in Python, this code is actually going to have a lot of extra function call overhead. So the first call is going to be on, when we call next on this large sequence, the first call is going to be to next on the inner sequence, which is the filter, which when we call next on that, calls next on the map, which calls next on the underlying sequence that we're mapping over. So we have three extra next calls for every single call to next in the sequence. So it doesn't seem like a lot, but this is going to happen on every single element in our sequence, which can be potentially quite large. one thing to note is that if you were to write this code by hand instead of using map and filter, you would only have one call to next per element. So you'd say for element in some input iterator, you would evaluate the map in line by saying g of element. You would have your filter in line by saying, if not p of element, continue, and then you would just yield your thing. So to fix this, I wrote a class called gotanks.fuse.iterator, which if you have a scalar function like before, we can replace our call to map with a call to fuse.map. And what this gives us is instead of a map object, it's a fused iterator. This keeps track of all of the steps that we're going to apply to this sequence instead of actually building up some object that loses that information. But if we iterate over it, we get the same value that we'd expect from map. This becomes useful when you want to start sequencing things. For example, if we have some interleaving like from before, we can still see what all those steps are. And then when we evaluate it, we get the same result. The reason this is faster is that instead of using a bunch of Python function call overhead, I take all those steps and I wrote a little interpreter loop in C++, which just goes through that really, really quickly in a single stack frame and executes it. The other problem I talked about was map of map. So given two scalar functions and a sequence, if we apply map to both of them, we get this result. But this is actually equivalent to saying map of f composed with g. So we can fold those two map calls into a single map call with a function called f of g, which just calls f of g of x. When we call map of this, we get the same value. However, if we were to write this f of g by hand, we would not actually call f and g. We would just inline the body. So to take a look at the bytecode for these functions, if we have f, this says load fast, load const, binary add, return value. You can look up what those mean later. G is almost the same, except we're going to use a binary multiply instead of a binary add. So the f of g does basically the two things together, except there's no temporaries. So our goal is to take our map of f of map of g and generate this f of g that has the same properties as our handwritten code. So to do that, I wrote a function called compose, which takes two functions and returns a new function. And this function actually has the same bytecode as the handwritten version ourselves. So if you use gotanks.fuse.map and you say map of f of map of g, now we only have one step, and that's a single map step of f of g. And it gives us the same result. Thank you.
Thank you, Joe. Next up is James Powell.
Thanks.
While James is getting set up, we all use Python, we all use a lot of the libraries, and there's some very valuable and very important people behind those projects who contribute a lot of volunteer time to make them work. I don't know if this question came up in the quiz today, but it has in the past. Who can name a core contributor to any of the major projects that we use? CPython, NumPy, Pandas, SciPy? Jeff Reback. What project? Pandas. Anyone else? Brett Cannon? CPython? Steve Dower. Who's that?
Nobody important.
Speaking of nobody important, looks like James's time is starting a minute ago.
Fantastic. So I want to show you some ideas I've had recently about a topic that I don't care enough about to write real slides for, but a topic I do really care about because I've spent a lot of time thinking about this. And I think the genesis of thinking about this idea came from a pet project that I had, and then just something very simple that I do in a Jupyter Notebook. You know, in a Jupyter Notebook, you have these magic commands. You put a % sign in front of something, and it does something different. In the case of prun, this isn't valid Python. It tells the notebook to do something special, like profile the code that you have. And you even have these cell level ones, so you can Cythonize a cell. You can even do kind of neat stuff like run shell commands from your Jupyter Notebook. And what's kind of cool is that those shell commands can also interact with the Python environment. So I can set a variable in Python, and then I can write a shell command, and the environment of that shell includes the state of that. It's kind of neat. Well, I decided that I hate PowerPoint and I hate writing slides, so why not create my own tool for writing slides? And I originally started with a tool called Scent. from a group called Suckless, and it was a very, very simple tool. What you had was a single text file, and in that text file, you would have each slide separated with lines. And so a slideshow might look something like this. Some slide is the first slide with content, second slide, third part is that's it. The problem is that's too stripped down. So I thought, wouldn't it be nice if I wrote my own version in Python? The original version in C was 1,000 lines. I can write a version of this in Python in about 200 lines of code. I was able to do it, and I thought, wouldn't it be nice if I could set the foreground color? So I can make this a red slide just to give impact, because having every slide the same color doesn't give the right kind of impact. And wouldn't it be nice if I could change the font on certain slides? Wouldn't it be nice if I could add small things here and there? And as this became more and more complicated, I started adding more and more directives. And I thought, wouldn't it be nice if my slides could run some Python code so I could display the time? And eventually it turned into this monstrosity. This is the very first version of my slideshow program and what the data format looked like. And you can see there's a million directives. Some of these directives include Python code that runs. There's this burn after reading directive because these directives would create a phony slide that I have to delete so the counting wouldn't go right. And I was writing Python code and cutting and pasting it, and it was horrible. This worked for a couple of presentations. By the way, you won't be able to tell which ones are in which tool because from the perspective of the output, it all looks the same. But it ended up looking like this. You can see there's timers, there's global variables. And I said, I need to take a step back, and I need to think how to do this right. And what I thought about was, I like to write Python. I like to write Python scripts. And back when I was a kid, we learned Yak in school. We learned Yak and Bison in school. And one kind of neat thing that a lot of us forget about those tools is that, yes, it's a parser generator. And yes, parsers are supposedly well-trodden in computer science. But I don't really want to write a parser. It's still kind of hard to do. But one neat thing about Yak is it would embed C in the language. So this is actually a line of C that would just get embedded. Yak would just translate one file into C. So I thought, what are the sigils that are not available at the beginning of a line in Python? What are the ones that are available at the beginning of the line? And what if I just took a Python script and I added a couple of lines that I could identify specifically as not being valid Python because they start with a character like exclamation point or % that aren't valid Python. And I just used a regular expression transform to transform it directly into Python. And I realized that this is actually a very powerful technique, either using a regular expression transform or just using eval on it directly. And so I ended up with something that looked like this. Now this looks very complicated, but in fact, what I'm doing here is I'm constructing a Python object just using regular function calls. And I just have a little bit of extra language that just says, create a function here, pass it through these two functions, and take this. And what I can do now is I can create very complex object hierarchies with a very simple dialect for a fairly sophisticated data format. And I don't have to write a parser. I don't have to do anything except just notate what is actually originally maybe a Python file with a couple of sigils and either do a regular expression transform or just search for lines that start with my magic character and pass them to the Python eval. As a result, I end up embedding a Python interpreter into the DSL, whichever way you want to say that you're embedding, but you end up turning what was originally a data file into something that's actually a transpiled Python script, getting all the power of Python, not having to write a parser outside of a couple of really simple regular expression transforms, and you do some really amazing things with this. Now, obviously, probably I'll go back to this in the end because this is probably the easiest thing to do. But I think it's a very interesting idea. I think there's a lot of legs to this idea. And I've been thinking now, as I start writing software, I don't want to write configuration formats that have includes. I don't want my data formats to start getting program behavior. I want them to be as simple as this.
Thank you, James. Got to say, I've seen a number of lightning talks. Pierre, if you're here, you're up next. Number of lightning talks, but that's the first one where I've ever seen someone reinvent LaTeX and then Java, and then Ruby, all in one lightning talk.
Not HTML.
So since we're getting set up, let's hear a few more core maintainers, because we do want to recognize these people. They contribute a lot. Does anyone know anyone who works on NumPy? Nathaniel Smith. Is he actually a core maintainer or just very, very active? He's officially now? I know he's very active.
On the Thunderbolt on the other side.
I'm not going to repeat that on the microphone. Anyone else? Anyone know anyone who works on scikit-learn? Yep, good. Sorry? Gael? Yes? What about Jacob? Yep. What about SciPy? Does anyone use SciPy?
You know how I fix it.
Nobody here uses SciPy. Okay. Does anyone use AstroPy? No? No? All the astronomers have gone home? Is it a clear night? Sorry?
I just need to mirror.
Thomas Robertson. Matplotlib. Tom Caswell. All the ones coming to mind now are, for me at least, are the Anaconda ones, and I know who those people are. We good?
Yep. All right, cool. So the other week I was competing in a competition for predicting water failures with a couple friends, and we had this big feature space looking at everything from soil data to topological data to where exactly the pipes laid and weather data. And we just needed to create this classifier where we needed to hit a prediction within a 6-month window. So as we kind of divided the tasks, I was in charge of creating the temporal features. So I used the Prophet library, which many of you may have already used, and TS-Fresh to do that very, very quickly. So I want to show you how I did that. So first, let's just define a simple function for creating an arbitrary time series with some trend and noise. And it'll look something like this. Then I went ahead and assigned a period. So in this case, the contest required that we make these 6-month predictions. So we needed to know if this pipe would fail within the 6-month period. So that's why I'm assigning a period here. But that would be, some identifier that you would want to group on, with some other type of forecasting experiment. So in this case, it looks something like this, where I just take the year and the month. And then we have our time series that looks like this. So the Prophet library makes it really easy to go ahead and apply a forecast. So if we passed in that full time series, we would get out something like this. You can see the forecast vector beginning right about there. So the next thing I did was create a feature prep function. This is really ugly because I wrote it just earlier today. But basically it goes through and it says, okay, for a given 6-month period, for a given time series, we'll go ahead and make a 12-month forecast. And then the first 6 months of that forecast, we're going to take some descriptive statistics over it to squeeze out some features. We'll then take the percentage difference with the prior 6 months over the forecast vector, and then we'll squeeze out the same descriptive statistics from that. So when all is said and done, it goes through all the different 6-month periods, creates all the different forecasts, and then we get back a or a data frame that looks something like this, where we'll have like the trend sum, the trend mean, the trend median, any of the descriptive stats that I passed in here. I just did sum, mean, median, min, and max. And then if you scroll all the way over here, we can see some of the percentage change descriptive stats that we squeezed out as well. So that's all well and good. We went from that one kind of discrete interval to 91 features, but we're not done. So we went ahead and passed in another data frame to TS-Fresh, and we are grouping on that column ID, and it knows that DS is our time series. And that will squeeze out another 795 features. So TS-Fresh is pretty exhaustive in some of the features that it'll create. Not all of them help explain variance, so you may want to limit that space somewhat. But very quickly, we went from just that one feature, the discrete interval, to 795 plus the 91. So then we just go ahead and merge those two data frames, and we get 885 time series features. So pretty nice. I did relatively small data here, just those 13 steps. Obviously not enough to train a classifier. But if you are in a situation where you think some additional temporal features might help improve the performance of a classifier, this is a quick and easy way to get there, and just using some really simple tricks and some really high-level libraries. That's it. Thank you.
Thank you. Up next is David Nicholson. Ready, sir? Go. While he's getting ready, I just want to call out a couple of sponsors again, since we're down to the last 2, maybe 3 lightning talks. It's really exciting. I'm seeing a lot of companies sponsoring that I've not seen sponsor PyData before, and that's really cool. You can all see the signs up here: Bloomberg, D-Shore, Capital One, DAT, Elasticity, Kubol, Zero AI, Sticker Mule. Sticker Mule's sponsored before. We've been buying stickers off them forever. But it's really exciting to see new companies getting involved, helping support the community, and we're really happy that if anyone representing them is still here, really happy that you decided to help sponsor PyData, and we hope that'll continue because it's great to have more involvement. David.
Thanks. Hey, how about Ralph Gomers for SciPy maintainer? He helped me through my first commit, so I want to give him a shout out. Hey, I'm David Nicholson here from Emory, where I'm a postdoc in the Sober Lab. I gave a talk about neural networks for segmenting vocalization with Yard and Cohen this morning, but now I'm here for my night job, which is teaching data science to scientists. How many people in this room, and you don't have to answer because that would be irresponsible, as I learned from Gina. How many people have like an academic background, which can include starting grad school and then saying, screw this? Okay. So for the 10 of you, how many of you still interact with people in academia? Yeah, okay, cool. Right, so you probably know all fields of science are now flooded in actual digital data that you can manipulate with your computer. Scientists really need data science training, especially grad students, not only to better deal with their data, but to have actual hard skills from your degree that you can use in academia and out. So not all fields of study or programs have recognized this need, right? You might think of astrophysics as being really good about this, like Jake Vanderplas, Katie Huff, nuclear physics, right? They're like the keynotes at PyCon. Neuroscience, we like to think that we're studying the most complex thing in the universe, but we still have a little work to do in this respect. And especially in programs, there's often this prerequisite pipeline. So I think all of us in this room, even though we might not have had like 12 years of calculus, are not afraid to just use scikit-learn. But if you want to take a machine learning class, often you have to have that in your history of classes you've already taken. So, and here's one list that a grad student put together in our program to emphasize this, how hard it is to get in these classes because they're very siloed. So we've been trying to address this need. At Atlanta, we have this BEST program, which is broadening experiences in scientific education. And our program manager, Tammy Hutto, along with Sarah Takushi, who's the student that put that list together, they just started organically this data science club, and it might not surprise you to find out that we've had a ton of people interested in that. Along with the club, we started a GitHub organization, which has really been a great tool to organize and also been a way for them to get some exposure to those tools. And also, I'm teaching a short course on scientific computing and data science, or as I wrote here, on data scientist. So our club, we've got monthly meetings. We're organizing on Slack, which has its pros and cons, but again, that's a way for them to see that. We give presentations on topics of interest, like Git and GitHub. And we've had panel discussions, so we've been able to work with PyData Atlanta and Anadata, which is another local group, which is a local group that has its own GitHub projects that our members can work on. And for our GitHub org, you know, we put all our repos based on the talks up on our org page. We have a list of contacts where we had everyone in the club submit. So that was another way for them to see what it's like to use Git. And also when we have to show professors and administrators, hey, we really need to address this need. If you have a list of 60 people who, without any reason for them to sign up and learn how to use Git except their own interest, and they're all on this page, it provides some really good evidence that this does need to be addressed. And then last but not least, we have our data science short course that we've been teaching. We've been using software carpentry classes as a basis. Some of the free books from Jake Vanderplas, like the Data Science Handbook, which is really good for how do I do this command I learned in MATLAB in Python. And then Elegant SciPy, I just want to give a shout out to that. It's a really awesome book. because it's very example based. So it starts out with talking about how do I go from a gene to a protein, and then how do I do bioinformatics, and then how do I use NumPy. And it's super user friendly if you're someone who's like still afraid of a computer, and you're doing your analysis in Excel, but you work in the lab every day, right? So, and last but not least, our class project is sort of trying to tie all of those things together. And on my last slide, I'm not going to segue to it by saying last but not least, but just to emphasize the take-homes, we need data science education. As scientists, there are these open source tools out here, but please check out my links on the slides when I tweet them out and learn from our trial and error. And thanks for listening.
Thank you, David. I'm going to take advantage of being the presenter here and insert my own lightning talk because I can. Awesome. Which means I get to do my own timing, which means I get to cut myself off. So this could go on for a while. It won't. Okay, my name's Steve Dower. I work at Microsoft. I'm also a CPython core contributor, as was shouted out before. I'm actually speaking tomorrow. I've got a full session on this, but I decided to pull out one slide now, and in fact 2 slides, and go a little deeper for all you lovely people who stuck around today. I've already chatted with a few people through my slides, and they're not real excited about me not spending much time on this. So my talk tomorrow is why do we need security transparency in Python? The full answer for that will be tomorrow, but this is a sneak peek because I suspect not many people have actually seen how to exploit a security vulnerability in Python. And that is what this is an example of right here. We're probably all vaguely familiar with the idea of buffer overruns being a bad idea, remote code execution being a really bad thing to let happen. But how does it actually come about? What do you have to do to make that happen? So what I have here is a sample. It's taken from the website below. I didn't come up with this. This is an example packet that you would send to a Python server that's written in Python. I suspect it'll say at the link, I think this one was fixed in about 2.7.9 is when this bug was fixed. But essentially what this would do is a server using the socket.receiveFrom function is going to receive this message, and it's going to copy it into a local buffer. That buffer is allocated on the stack. So if you remember back to your early software engineering, maybe you learned C, you dealt with a stack. Certainly Python has a stack, but this gets written into the C stack. This is just flat memory that is all just ones and zeros, and the program logic determines how it gets interpreted. So there's a section that this gets written into and gets called data. Somewhere else in memory, adjacent to that, is another section that says, this is the next bit of code to run. This is the return address to jump to when we're finished with this function. There's other bits of this memory that say, here is the start of my parameter. Here's where the important information is located. So it's this mix of data, local variables, addresses, code pointers, and it's all just thrown into one chunk of memory, which means if you find a way that you can overrun a data part of that, you can start changing the actual which bit of code is going to be executed next. So if you look at this packet, you'll see a whole lot of things that look like padding. And they are. If I take out all of the generated padding, that's just to fill spaces and get to the right place. The highlighted hexadecimal numbers are actually hex. Those should all have like \x escapes, but that looked ugly, so I left them out. But what this will do, if you're in the receive_from function, the C implementation in Python, certain versions, this would overflow a buffer. It just gets copied into a local array, no bounds checking, no range check, like all of that stuff just gets ignored. And you end up overwriting some variables. You'll see that the first 2 values are the same. That's to actually make it keep working. Because one of those values is important, and if you change it, then everything just breaks, and you don't get an exploit, you get a crash. So we have to write in the value to make it work. The last value, the one that starts with E0, that's actually the address of the system function in the particular version of glibc that this is trying to exploit. While security vulnerabilities are scary, while buffer overflows are definitely vulnerabilities, you have to be very, very precise to take advantage of them. Because if you sent this to a machine that doesn't have the system function there, you're not going to get a vulnerability. You're not going to get an exploit. You're going to get a seg fault, which is valuable in sometimes, but not necessarily what you want. It also happens to continue overriding, and it overrides the argument to that function, which means this code run on a machine that it's targeted to is going to start an instance of bash using the system command. It's a proof of concept. That's not a full vulnerability. You'd more likely have something fun like this. Something that's actually going to use a good programming tool that can run arbitrary code, that in a single line past a system can download it from anywhere on the internet, compile it, no validation, no nothing. It's just going to grab your arbitrary code and run it on someone else's machine because they didn't patch their version of Python. This is the scary part of the story. If you want to hear the happy ending, you have to come to my talk tomorrow. It's going to be in the afternoon. Look it up. Why does Python need security transparency? My name's Steve Dower. I will see you there. Thank you. And I didn't go over at all. Our final talk. Is she ready?
Yeah.
Yay!
I'm just going to plug in and plug in.
Okay. While Jessica's getting plugged in, let's have a look at these other sponsors that are over the other side. Microsoft hosting. Isn't it great to have such awesome facilities to hang out in? Yeah, you can clap. You can clap.
Yeah, you can sit down.
Obviously, I work there. I wasn't directly involved in setting this conference up, but we're thrilled to have you and happy to welcome you and hope to do it again in the future. Anaconda's been sponsoring PyData since the start, which is great. Ameritrade, JP Morgan, 2 Sigma, Caserta, and Crux. Man, I love seeing these companies that have not sponsored before. Hope you guys stick around. It's wonderful to have you as part of the community. And with that, our final lightning talk for the night. Whenever you're ready.
Yep. Give me a minute.
Is that Flux?
Flux. Turn off the Flux. Give me a minute.
Flux is saying we should all be in bed now. If you don't know what Flux is, by the way, it adjusts the temperature of your screen so that in time with the sun setting. So it actually makes it so that you don't get eye strain late at night because you've got a ridiculously bright screen. But it also means that during the day when your eyes can handle it because outdoors is bright, your screen can be bright as well.
I can't even see the Flux turn off for an hour. Am I at the right place to turn off an hour?
Disable. Next one down. Don't use it if you're an artist because it's going to confuse you.
Okay, so my name is Jessica Ford. I work with the great people at Project Jupiter, and you can too. So this point of this talk is that all of you can be working on Project Jupiter, and I would hope you all end up working on this. So the last time I was at a Python conference that wasn't this one, I gave a talk on reinforcement learning, now that we have Jupyter Lab, there is a great new way to explore repos. We have an IDE. And so instead of me just going through the environment, the notebook like this, I can, let me see if I can drive it well. And drive this, where's my, I can't see this. I can't see my mouse. Top right. Oh, there it is. Sorry, it's hard for me to read my mouse at the same time. I can actually highlight all this and send it to the console. And now this whole thing is running and everything talks to each other and it's all modular. And we have a lot of really nice additional tools. So for example, let me see if I can do this all at the same time. I could actually put up this puppy and now I can render it. So it renders Markdown. And all of this is really great, right? And I can keep on going about all these great things. But you know what? Like, you guys probably actually want to be able to get it on your own. So I set up a delightful little environment.yaml If I click on it twice, it'll open. Go. So it has everything you need, and that sounds cool, but that's actually not cool enough, because ultimately what I really want is all of you guys to be able to play with it on your own. So I'm going to show you guys another tool. So I'm going to pull up this thing. Sorry, I'm trying to, how do I get the mouse? Where's my mouse? Let's see. Oh, did it disconnect? Is it working? Where's my mouse? Where's the mouse? Can't get a hold of my mouse.
Top right again.
Top right. Is it top right?
Yep.
Okay. If I keep going right, does it end up going left? Sorry, I can't figure out how to drive this thing. Does anybody have like, where is it? How do I get it on the other side? Do I go left to get to my side? There it is, okay. If I go to Binder, now you guys all can play with it as well. So if I go, so this is actually a My Binder instance of the same notebook, and it has everything pre-installed, and you guys can all play with it, which is great. And we also take RStudio, we take Jupyter Lab, we take Jupyter Notebook, and so you actually can use it on your own right now. It's totally live, and there it is. But I think, since open source is really important, I'm going to cut to some other things that we can do with Jupyter Lab that I thought you guys might find really fun. So I'm going to show you one of my favorite things about Jupyter Lab, which is real-time collaboration. And so I'm going to go open up, driving this thing. And so this is a notebook that I have that I've been working with for a while. We play with it all the time, and I can run things live, right? It just runs. And let's see. And I'm actually sharing this with Dan. So let's see, where are you, Dan? Let's see.
I can see him.
Okay.
A little bit.
Where is Dan?
Near the top. There's a markdown. So there you go.
Ah, there he is. There's Dan. See? So that's Dan. So now when you connect Jupyter Lab to Google Drive, you can do real-time collaboration. Again, these are all different projects that are open source. All of you can work on it. We have sprints on Friday. It's totally great. One of the things actually that I would really hope you guys all think about is possibly even building your own extensions. So Jupyter Lab is entirely modular. We use all the latest tools in web app development. We use TypeScript, we use Yarn, all these sorts of things. And there's a really great tutorial online on how you can build extensions. We have an XKCD extension, which are really great. So please contribute.
Thank you. Let's thank all of our speakers. That is lightning talks for tonight. Hey, keynote starts tomorrow at 9 a.m. It's going to be back in here. We have a Nobel Prize winner in here. You'll want to come in here, Tom Sargent, speak. Very interesting, man. Looking forward to it. We'll see you tomorrow morning, 9 a.m. for the second day of PyData New York. Thank you.